for teaching Python. So Geany. The other thing I want to mention is, suppose you need more practice, you want more practice problems, right? A good use of it, this is actually where AI can be pretty useful, where you could upload a PDF of my problems and tell an AI model to, hey, generate more questions based off of this professor's practice exam. That's a perfectly valid use of AI. That's a perfectly legitimate one, right? Because you're still novices in the area, so not a bad idea. Now, this is essentially going to work like idle. The only difference is that you'll have a window pop up for my output. So no, there shouldn't be any difference. I'm just using a different editor. It works exactly the same. The difference is that it's a bit lighter than VS Code, and the autocomplete is very simple. The stuff built into Python, and then if I create a variable, it adds it to a list of symbols that will then autocomplete. Okay. So practice exam. Let's go ahead and go through this. True or false, the computer science is the study of computers. We'd hope that that's false, right? Computer science probably is best defined as the study of algorithms, all right? So computer science being the study of algorithms. Where does the word algorithm come from? Anyone? Yes? Yes, the Latinized name of Al-Khwarizmi. Al-Khwarizmi, a Persian mathematician. So it got Latinized to Algorithmity, right? True or false, Alan Turing is often considered to be the first programmer. No. False. What is Alan Turing famous for? He's often referred to as the father of computing. I'll accept any of the following answers. Cryptography during World War II, the idea of Turing completeness, the idea of the Turing test, the Church-Turing thesis, and mathematically proving what computers can do. But simply put, it's going to be a bit of a lighter question on the exam for this history stuff. Who is Ada Lovelace and why is she an important figure? Because she's the answer to the previous question. She's the one who's generally considered to be the first programmer. Okay. For this page, besides reviewing your answer for computer science, what is computer science, what are algorithms, and then I would study what you gave me as your answer for your first lab. That's a hint. So that's your first page on the exam. Next page on the exam will be pretty much exactly like this one, only half the questions. You'll only have 5 of these, and then the rest of the space will be taken up by 3 of these. So, all right. Would each of these evaluate into Python? In Python. And again, what we're going to do here is that it's just order of operations. So multiplication, division, multiplication, we just simply go left to right. 2 times 3 is 6, divided by 6. 6 divided by 6 is just a fancy way of writing 1. 1 times 100 is equal to 100, right? Should be able to plug this in and double check it, right? It should be 100. Okay, so next, 1 mod 2 plus 3 mod 2. This question exists for one reason and one reason only. To remind you that modulo arithmetic is A, a thing, and B, has the same precedence as multiplication and division. So these modulo operations occur first. So what's 1 mod 2? That is just going to be 1, right? 1 divided by 2 gives us a remainder of 1. And 3 divided by 2 would give us 1 remainder 1. So all we care about with modular arithmetic is that remainder. So it makes actually the math pretty easily. So this is just a fancy way to write 1 plus 1, which is 2. Right? A lot of the math here is going to look complex but be exceedingly simple. Like this one, -1 plus -10.5. Did you learn how to do your negatives, right? So over here, and the question here is, making sure you understand that it is completely valid to add an integer and a float. So you get a -11.5. I should also mention that on the actual exam, these are all going to be multiple choice, okay? It's just to speed up grading on my part. Okay, another one where we do order of operations. 4 plus 5 minus 3 times 2. It isn't this. This is not what gets done first. What gets done first is the 3 times the 2, because multiplication comes first. So we're just going to replace this with a 6. 4 plus 5 minus 6. And nothing in here is going to require a calculator, despite any appearances to the contrary. Make sense? So if you see something that looks like it's going to require a calculator, like this thing, it doesn't require a calculator, right? There's a trick or something, right? 0 times, it doesn't matter. 0 times anything is 0. So this is just 0 minus -1.0, which is equal to 1.0, right? Or -1.0, my bad, right there. Got too worked up in this kind of thing. Also part of the reason why I do the multiple choice is that it's a bit harder to accidentally drop a negative like I just did right there. Okay. Speaking of dropping negatives and stuff like that, here's another answer that's negative. This one's pretty easy. 8 minus 20, right, is equal to -12. This one, and then these next ones are here to remind you of the other operations that exist. 7 divide 3. 7 divide 3 is the same as basically saying 7 divided by 3, but we only want the quotient and ignore the remainder or the floating point. So the closest thing we can divide into is 6, right? 3, 6. So it'd be 2 point something something something, right? 2.3, I believe, is the answer for this. But we don't care about that 0.3, right? It's 2 and a bit. And we don't care about that bit. So that's 2 plus 2 plus 3. We've seen that already, and you've certainly seen it plenty of times. 2, 8. 4 mod 2 times 3. Again, we are going to be doing, just because it's just because PEMDAS, please excuse my dear Aunt Sally, right? Just because that says multiplication division doesn't mean multiplication happens before division. It means multiplication and division and modular arithmetic are all on the same tier, and you just do them left to right. So it's not 4 mod 6. It is 4 mod 2 times 3. 4 mod 2, 4 divided by 2 is 2 remainder 0. But what we care about is the remainder. Any even number mod 2, 0. Times doesn't matter, it's still 0. All right. One I do love doing. Big number, divide, really big number, right? This is going to be 0 point something, but we don't care about what that point is, right? We just care that it is 0 because we're using two division symbols here, right? This is integer division, right? So if I were to rewrite this like this in long division form, everybody see what I'm doing there, right? It would be, we'd have the quotient over here, and then we'd have remainder, and then we'd, sorry, be the other way around, sorry, not bad. If we wrote this as long division as 52k divided by 2, 3, 4, 5, 6, right, 24 million, right? We know that the quotient would be 0 and there would be a lot left over. Right, can't divide into it. And all we care about is this quotient. But you don't even have to do this nonsense. You just know it's going to be 0. Finally, reminding you what this is, because definitely one of the choices on the exam will be error on the multiple choice. Yes? Sorry? How did I do this last one would be 0? Because this number is so much smaller than this number. When we do division, when you have a quotient that is bigger, when you have a, my words are failing me here. When you have a numerator that's bigger than a denominator, right? Or smaller than a denominator. When you have a numerator smaller than a denominator, which is effectively what this is, that means you're going to end up with a fraction that isn't that's going to be less than 1. Because it's less than 1, we know that if we translated it to a decimal format, it would be 0 point something something something, but we don't actually care about what that something is, because when we have 2 slashes, what we care about is integer division. It's got to be a whole number. It can't have a floating point. So that means that it has to be 0. Make sense now? All right. So, like I was saying, this is just to remind you that caret is taken already. That's not what we do in computer science to do exponentiation. To do exponents, we do 2 stars. So this is 100 exponented to 2 times 2. It's exponentiation first, so it isn't 100 to the 4th power. It is 100 squared times 2. Sorry, 10 squared times 2. Blech. 10 squared times 2. It's 10. I was getting the answer in the question confused. 10 squared times 2. 10 squared is 100. 10 times 10 is 100. Times 2 is equal to 200. All right. What are the values of x, y, and z after the following statement? This will be on, something like this will be on the exam with 2 variables instead. So we start out with x, y, and z. So we set up 7, 8, and -5. And what I would like to do, and you don't ever want to try doing these in your head. If you're trying to do these in your head, you're probably going to get them wrong, right? Because you're trying to keep multiple variables in your head at the same time while doing mathematical operations on it. Don't torture yourself. X is equal to x plus 1. What is x's value? X is 7. Plus 1 is 8. So we're going to be storing that value in x. So now x's value is 8. Y is equal to x plus y plus z. So x is equal to 8 plus -5. 8 plus 8 plus -5 is 16 minus 5, right? So that makes this equal to 11, because we're going to be storing it in y. Next probably is the worst part of this, which is z plus equals 1, right? Which is to increment this value by 1. And for a lot of you, instinctively, if you're rushing, means you'll write down -6. But incrementing means adding 1, right? This line is shortcut. It's a shorthand for z is equal to z plus 1. Got it? So this is equal to negative 5 plus 1, which is negative 4, and then we take that and we store it in z. So the value would be negative 4. All right. Evaluate whether the conditional expressions, each of the conditional expressions to true or false. Now, of course, you don't want to leave this part blank because, as everybody knows, that means just by guessing you have a 50-50 shot. So, anyway, the way this works is, again, these statements are expressions with equal to, greater than, or less than, or greater than equal to, or less than or equal to. They evaluate to either true or false based on what the values are. Next, the other rule, or and. Or means at least one of the two sides has to be true for the whole thing to be true. One, or the other, or both. Ands, on the other hand, say both sides need to be true for the whole thing to be true. Finally, our last trick is not. Not just turns the thing it's in front of into opposite day. So it says, hey, so if we, for instance, if we look at this problem 2 over here, where we have not false, that's just going to evaluate to true. Make sense? Similarly, true or 3 equal 2. Well, the 3 equal 2 is going to be false, but honestly, we don't actually care anymore. It's like multiplying by 0 in the math problems. True or, once we know that one side of the or is true, we don't really care about the other side. In fact, your computer, most programming languages, when you hit that case where it's true, or it just doesn't even bother executing the other bits of code to save you time, to be more efficient. True. All right. So now we have an and statement here. And the not applies over here. Okay? So first let's do this side of the and. 3 less than 10. That's true. So then we have this other side. Not 4 less than 2. 4 less than 2 is false. 4 is not less than 2, right? We put a not in front of this now, so it's not false. So this becomes true. So we've solved both sides. Both sides say they are true, so the whole thing is true. Make sense? This one, honestly, you can't really get until you check it on a computer. Or rather, you can't be 100% sure until you check it on a computer and then justify it after the fact. That's a really crappy way to do it, because and that's probably the reason I put it on the practice exam, because it's one of those things to kind of give you a reminder. So 32 divided by 8. Divided by 8 gives us 4 over here. 32.0 divide by 8 gives us 32 divided by 8 with a single division gives us 4.0. So the question's really asking, is 4 the same as 4.0? And yes, it is. Mathematically, it makes sense, but there's always the question of, well, technically one's an integer, one's a float, right? Does Python work in the least surprising way possible? Yes, it does as a rule. Python does. But to kind of explain why, to make sure that you understand this, anytime you do any operation that involves a float on one side and an int on the other, what happens to the int? It gets converted to a float. And that's how we know that, and that's how it checks to make sure those two things are equal. All right. True. All right, and then of course the last one, I always love to make one of these hell problems. So parentheses still matter, so we're going to do that. All right, so we've got a true or, and again, it doesn't matter because, so we've got a true or 3 less than 2. That's false. But like I was saying, this doesn't matter. We see over here in these parentheses, we have a true or false. So this entire thing, this small clause between this second parenthesis and what closes it off is true because we have an or statement with one side being true. Then we have an and not, and again, we've got parentheses. We always want to do what's in the parentheses first. False or true, again. We're going to take what's in the parentheses and replace it. That's true. But then we have a not operating on it. So then that becomes false. So inside these parentheses now, we have false, we have true, and false. Both sides of a false statement need to be true. Both sides of a false statement must be true for the whole thing to be true. So since we have true and false, that comes down to being false. And finally, we have this not on the outside, which flips that false to true. And for those of you keeping score, yes, all the answers to these were true. Yes.
So for the last one, the overall answer was true?
Yep, the answer for all 5 of these were true. I want to be clear here. I am the type of professor who would put all the answers as true on an exam, and I have done so before. I'm probably not going to do so because it freaks you all out, even though statistically speaking, you should be able to expect, oh, if I get 5 true-false questions in a row, 1 out of 32 of those times, they're all going to be the same. They're all going to be true. And 1 out of 16 times, they're all going to be the same. Yes?
So what if you have false and false? Is that true?
False.
False and false is false?
False and false is false. You need, for it to be true, you have to have both sides to be true. Yes?
If you have true and false, then
That true and false becomes false.
which is the last one?
Right? Yep. For an and statement, both have to be true. Yes?
So for this problem, like, where the first expression was like not whatever it was, does that like not contain like the whole problem? Or, like, I think I'm just confused why it's not false and why it's false and true. Like for the one we just did.
For the one we just did, it flips the entire thing because I have to clean it up right now. Excuse me 1 second. It flips the entire thing because it's in the parentheses. I just got messy while I was going over it. Limitations of the format.
Okay.
This was meant to be a hideously hard one, by the way. Okay, the questions on the exam are generally probably more closer to this one. Yes. True or false is true. Yep, because if for an or statement, as long as one side is true, both sides, the whole thing evaluates to true. Okay? All right. Slices, strings, and range. So like I was saying, this part of the exam will be on this page over here, right? And then you'll have only 5 of these rather than 10. They're still going to be worth 10 points total. They'll just each be worth 2 points rather than 1 point. Okay? String, slice, and range. Consider the following code. And there is an equivalent here on the actual exam. Okay? An apple a day. And B is Ansindet eine Schmier Swangbe, okay? Which is gibberish, sort of, okay? You'll see in a minute. Okay, what would each of the following expressions evaluate to in Python? So this is to make sure you study your slices, right? A, 3. Now, what I would highly recommend doing in these kind of problems, right, where I give you stuff and I'm asking you for indexes of things, is you go over here and you write down 1, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, or maybe you do every fifth one. So you maybe put down 1, 5, 0, you know.
So the spaces count?
Yep, the spaces count because they're characters as well. Right? Spaces are characters. 11, 12, 13, and so on and so forth. Just to make sure you know, and if we have to write more, we will. But there we go. So here, we're going to go with, I think a purple now, why not? A3. So index 0, 1, 2, 3 gives us the letter A. If you put quotes around it, great. If you don't put quotes around it, I'm not going to care. Whether or not you've put quotes around your string in your answers is a moot point because you could argue either way whether it should have those quotation marks or not. Now, the slice 3 to 8. Now remember, slice notation works the exact same way as range, which is so we start here on the first one, and then we go up to, but don't include the second, which is 8. So this is 3, start at index 3, go up to, but don't include 8, which is fairly straightforward since 3 up to not including 8 is apple, right? Don't have to worry about B yet because we haven't asked a question about B, right? And apple a day. So go up to but not including 8. So we're going to do apple. Right? Now we've got basically this nonsense over here. With string concatenation, we're just going to go left to right, okay? And break down each of these parts, then add them together, okay? B, -2. So how do negative indices work in Python? Yes?
You go backwards.
You go backwards. So this is -1, this is -2. So -1, -2. So negative B2 is B. A3. Oh, we solved this one already, right? We solved this as the first question. That's an A. Right? But if you need to double check, 0, 1, 2, 3, it's an A. Okay. This one is a bit of a troll on my part. Okay? 1 to the end, wherever the end is, and we're going down by ones. So in other words, we start from index 1 and we're going down by ones. So we're going to left. So it is going to be 1, 0, and then we're done, right? Make sense? We're going the other way. If it was, if we had it being, if this was 1 instead, it would be this entire thing of an apple a day, right? But since we're going the other way, it's just NA. And then that's NA times 2. Okay, and do we remember what happens when we multiply strings by a number? You don't have to remember the official name for it. You can just tell me, yes.
It's the same string. I mean, well, not the same string, but the string, the amount of time.
Yeah, exactly. The official term is replicate, but yes, it gives you that string that number of times. So it becomes nana. So the entire thing is banana. All that work for banana. You know what? Just a banana. What could it cost? $10? Arrested Development. Good show. Okay, yes.
I'm sorry, can you explain one more time how like that last one works, like the one double colon and then the negative one?
Let me do the next one and see if we need to go back there. Okay. So again, over here, this is 3 parts. When we have 2 colons, it's split up into 3 parts. When you have 1 colon, it's 2 parts. 1 colon is just start and stop. Over here, when we have 3 parts, we have start, stop, but what this one is implied, and then step. So 1, starting from index 1, all the way to the end, with a step of 2. Here we had a step of -1, which meant we went left. We basically went from where we are to the beginning. Here, though, we're going to go to the end by 2s. 1, 2, starting at index 1. So that means basically what? We're going to be going through and doing every other letter, in other words. Okay? So here we've got H. That starts at index 1, and then we're going up by 2s. So I, D, D, E, N, right? And we can notice that we've got 1, 3, 5, 7, 9, 11. Space, M, E, S, S, A, G, E, which is HIDDEN, hidden space message. Hidden message is the answer there. Make sense? Now, do you still need me to answer that question?
Yeah, because I think I'm just confused with the negative, like why it's back, like why the response is backwards.
So by default, what we're doing, we've got word is equal to, let's go with Taco Tuesday, right? Then if I do word, so I'm going to go ahead and print word, and then I'm going to create a slice over here. And if I start from, if I just do this, this basically says from the beginning to the end, doing anything. So I just give just beginning to the end, figure it out for yourself. We're saying to Python, and so it does Taco Tuesday. Same thing over here, beginning to the end with the default step of 1, right? Which is the same as me putting 0 to 9,000 or whatever length of word. That's why we can just simply write nothing. It just kind of figures it out. And then by 1, and this again is the entire thing. If I go up to just basically index 0, 1, 2, 3, 4, I just get taco without the space. Now, if I wanted to go backwards and get OCAT, right? If I wanted to get OCAT, it's not enough for me to say start at 0, go down and go to -4. That direction doesn't exist. We can't start at 0 and end at 4. We have to start at 4 and go down to, but not include -1, because there 4, let's see, word, -1. So instead what we're going to do is we're going to say start at 4 and go down to the beginning. So the negative allows us to go backwards, go the other way. Make sense? And the way I did it over here was a bit of a contrived example in order to get that. All right, complete the function. The function takes in a string argument text and prints it in reverse. This exists for one reason and one reason only, which is to tell you that if it works, it works. Because there's too many ways to do this. Def, print, reverse. Take some text, and we want to get the reverse. So go ahead and if I'm just simply gonna give back. Wait, what did I say? It just prints it in reverse. Okay, so we don't even have to return. We're just gonna print. Okay, so. Okay, if I just leave it at this, I'm just gonna get what I put in. Print, reverse, echo. Right, then I'm just gonna get echo back. So what I'm going to do over here is I'll make myself an output just to kind of help myself. It's an empty string. Actually, I don't even need that right now. So there's a bunch of different ways I can do this. First, print reverse. And by the way, you don't need to put this line on the exam. The only reason I'm putting it here is so that I can test the code and run it and show you that it runs. First thing we can do is we can use what we learned from last time about slices, what I just mentioned a few minutes ago, which is, or a few lectures ago, which is that I can do beginning to the end or rather from the start point to the stop point, but in reverse. And you'll get okay, right, for echo in reverse. If I did Taco Tuesday, we're going to get Yadsuit Ocat. And of course, if I do Taco Cat, I get something completely useless because Taco Cat is a palindrome, meaning it's spelled the same way front and backs. So not exactly the best test. So we'll keep on Taco Tuesday. Okay. Now, this is what I mean by there's a lot of different ways to do this, because there are. I think it's just called reversed in Python. We were talking about this in 2168 because we had to go over kind of the same kind of issue. Oh, reversed object. Okay, so I have to turn it into a string. Also valid on an exam. I would probably give him credit even if you didn't put in the string part. I can't turn it into a string. Reversed text. Interesting. So is it just reverse? I could have sworn. So why doesn't it give me reversed? It should just be able to give me a reversed answer. Oh well. Moving on. But what if you forget how to do slices and stuff? Okay. Well, we've got a couple different ways. We can have our output, which is equal to an empty string, and we use an accumulator. And we print our output when we're done with it. Okay, so for letter in text to iterate over this. Okay, that's one way to do that. And what we'll do is that normally what we would do is we would write something like this. Output is equal to output plus letter. But that just gives us the same thing, Taco Tuesday. Now, why? Because it adds in the T, then it adds the A to the end. Then it takes what we currently have, the TA, and it adds the C to the end, then takes the O and adds TAC to O. And so it just keeps adding it to the end, which gets us the same result. We want it in reverse. Fortunately, the issue is we're adding it to the end. We add T to the end, then A to the end, then C to the end, then O to the end. If, on the other hand, we added T to the beginning, then A to the beginning, then C to the beginning, then O to the beginning, then space, then 2, right? Then we'd get it in reverse. Everybody see how it's reversing? So actually, adding this in from one end to the other isn't so bad. All we got to do is just flip this around. Take our output, and our output's going to be equal to the current letter we're looking at, plus what we've already added on. Make sense? Okay. And I'm just hitting the wrong key for run, and that gives us Yad Seut Okat again. Sounds like a really weird magic spell. Okay. So, next. What other ways are there to do this? Too many. Okay. We can also do for index in range, right? Text, sorry, range, length text. And this would give us the indexes 0 up to, but not including the last possible index, which is length of text. Then we could just simply get what the letter is by saying letter is equal to text index. Now, and then we get into the same issue we did have. We got to put the letter there. But what if we're not exactly thinking creatively like that and we're just stuck on this format? Right? So there's a couple different ways to do that. The first is to realize, wait a second, I can go in reverse through my range. Down to -1, -1. And then this goes and iterates through this in reverse. Index out of range, where did I mess up? Oh, yeah, because this needs -1s everywhere. Sorry, 1 second. Oh, no. Let's see. Give me 1 sec. There we go. So this one's tricky and not tricky at the same time. It's part of the reason I put it on the practice exam. Okay. I think the equivalent on the exam is that I give you a for loop, first off, and I ask you to print out the output of the for loop. And then I ask you basically a task to print out some numbers. I'll talk about that in a bit, but basically print out some numbers in a certain order. So maybe all even numbers less than 50, or all numbers from 50 down to 1, or something of that equivalent. All right. Next page. This page is definitely on the exam, pretty much word for word, only the code changes, which is I ask you to draw something, and notice that it says 10 over here. You don't have to be like, okay, what is 10 pixels? You just draw, and it's all about being relative amounts. For the record, I do try not to, on the exam, I recognize that basically some people are almost as bad at art as I am. Now, you may think that I'm exaggerating, and then you're worse. And no, I've been tested. I am the worst. I've had to sit for one of those intelligence tests where they basically, it's fun. They give you an image, and they ask you to draw, look at it, memorize it, take it away, ask you to reproduce it, and then they ask you to reproduce it a minute later. I ended up in the first percentile. Not the 99th. 99th means you're better than 99% of the people in the room. First percentile means you're at the bottom 1% there. Not the top, the bottom. So I am quite bad at drawing. Okay, so that being said, I do not have any expectations beyond what I would have for myself. So the angles for this exam are 3. 180, which is just simply turned the other way, right? 90, right? Which is just, a square angle, right? A right angle. And then, of course, for this one, 45, which is just halfway between this. And so I understand basically if it's a mess, it was probably a 45-degree angle.
We're on question 10, right?
9 and 10. 9 and 10, they go together, yes. Okay, so suffice to say, this will be fairly straightforward. Okay, so first we have import turtle, Bob turtle. I generally speaking don't try to do trick questions. In fact, I have some disclaimer at the beginning saying, please note there are no intentional errors in code provided except in questions asking you to correct said code. That's just a standard disclaimer. I'm not going to ask you to fix anything in this code, in this exam, but generally speaking, I don't try to ask trick questions. Make sense? Like that. Oh, it's an error because it's not going to run. No. Okay, def question Ziggy, Bob and length. 4-step in range length. Okay, so Bob starts out facing this way, and he's going to be right over here. We're going to start over here. So Bob dot right 45. So he's going to be facing this way. One of the things I like to do on these kind of exams, by the way, is if I've got a piece of scrap paper and I'm trying this out on a piece of scrap paper, I don't necessarily turn my pencil or turn my angle. I turn the scrap paper. Okay, so I'm always drawing in the same direction. So Bob right 45. So he's facing this way now, down, and he's southeast now. And then forward 10, whatever 10 is. Then left 90. So that would be facing this way, right? We were facing down into the, we went down this way. So 90 degrees would be this way. So right angle, right? So boop, boop, boop. We're here. We just turned, and now we're facing this way, relatively speaking. And then forward 10. So go down as much as I went up. Got it. And then right 45. Right 45, well, I am facing this way. It's currently a 45-degree angle. So turning right 45 makes me face straight again. Conveniently, if you haven't noticed, I really like it when my loops basically make sure that I end in the same place I started or in the same kind of orientation I started. So that means I'm facing straight again. And so if I repeat this, right 45, go right 45, go forward, left 90, which makes me face this way again, and then up. Okay, so I see the pattern now. Each iteration of the loop draws a little tooth thing, a little triangle. So if I do that, I do 1, 2, 3, 4, 5. Notice that like I drew it very imperfectly, right? And they, you'd expect all of them to. It's not like that. It's does it matter? Not really. I just wanted to if you got the general shape, that's what I'm asking for. Make sense? So basically, we are looking for a little sawtooth pattern. 1, 2, 3, 4, 5. And if you do a bit too much, oh well. Okay. Now suppose I change the program to the following code. What makes this change significant? In other words, what controller or power does the programmer gain? Does the programmer calling the function gain from these changes? Now to be clear, so we notice that question Ziggy has Bob and length, and now we have Bob length and size, and we have the things in forward replaced by size. If you write question Ziggy 2 adds a size argument and changes it so that it moves forward size rather than 10, that's not what I'm looking for. What I'm looking for is essentially, well, what does it change? Well, if you put in 50, now it's going to look more like this. It allows the user to control the size of the drawing, right? So if you're just if you're giving me a axiomatic answer, I'm not really going to be happy with that. Here we're looking for something that says, hey, you can make the teeth bigger. Correct answer. Even though that's not nearly exact, it lets me know you understood the assignment, right? saying, oh, we've added another argument and replaced something. That just tells me, yes, that's what changed, but that didn't tell me what was significant. Make sense? Okay. If I were to study one problem on the exam, it'd be this one. Because I know for a fact that the hardest question on the exam, the two hardest questions on the exam are this question and the last one. Okay? Now, this one's interesting because we've got, let's look at, so again, no trick questions with these first two lines, which are turtle and bob.turtle.turtle, right? Just creating a turtle. The third question thing over here is what we need to look for, and you want to look for it that anytime you see that you're going to get a command over here that says bob.stamp, right? And if you remember what stamp does, it lets the turtle make a little belly flop, right? So basically it makes a picture of itself at the current position. And I say you can draw a dot to represent a stamp. So basically, I want, when you see a stamp, I just want you to draw a dot where the turtle is relatively. And no, I don't have a specific place the turtle starts. You could draw your first dot here, or here, or here, or here. As long as the resulting shape is fine. You know, I don't care. And really, I'm fairly limited into the types of shapes I can give you if you think about it, right? If I'm going, with the angles I'm giving you. Okay? And making sure that it's sane. Okay, now. So the turtle is going to be somewhere, and I'll draw a dot wherever I find him. So, also note that I do have a tendency to actually give my stuff meaningful names. Ziggy, because it's a zigzag pattern. Right? Length, because that's how long this is. I don't obfuscate my variables. Over the years, I have asked precisely one question where my variables were obfuscated, and that was the turtle question on the final exam a couple of years ago when we were over COVID. Okay? And that question was, here is to working turtle code. You don't have to make any changes, although I highly recommend you do so you can experiment with it. But the variable names are all things, they're all gibberish, essentially. Actually, what they are is I took the variable name and then proceeded to throw it through Google Translate, and then throw that through Google Translate, and then throw that through Google Translate until I ended up with more nonsense, essentially. So the variables did have some meaning, but they were essentially like Danish and Finnish and Japanese words that had been translated poorly from Mandarin. So anyway, but the goal of that problem was deliberately, hey, what do each of those variables do, right? What do they power? Do they give the controller, Can you actually document this code for me, because it's kind of crap? Yes?
So for the test, is there going to be any extra credit questions at the end of it, or towards the end?
I give you a freebie of asking you to anonymous. So the last page of the exam will have two sides, but the back of it, it tells you to tear it off. You'll automatically get credit for it, and it tells you to just please write down how you feel about the class currently. Okay, and you tear it off so that there's no fear of repercussion in case you write that I'm a horrible person who deserves to step on a Lego. That way I'd have to go through a lot of trouble of matching up who to who, right? But there's a bit of freebie. Also on the exam, if you give me exceptional answers or exceptional explanations for answers, we do have leeway to give you extra credit. Okay? But the other answer is that, the other answer to that question is, wow, we are moving slowly. Glad I started this. Is there is 105 points out of 100 on this. So you can miss 15 points and still end up with a 90. So it's just a bit of a mini curve already worked in. All right, let's work on this one. Okay, my diatribe about variable names is that when I name things row and dot as my variable names, those are usually hints. Okay? Those are normally disclaimers as to what we're doing. So it's a good kind of explanation that this for loop, the outer for loop, does rows, right? Makes sense? So I'm not going to try to trick you there. And that this for loop, for dot in range row plus 1, is responsible for drawing dots in some way. So let's go through this. For row in range 0. So rows values are going to be 0, 1, 2, 3, and 4, correct? Make sense? So we're going to start out with row being 0. Okay? Yes. Was that a question? Sorry, I thought I heard somebody. All right, for dot. So row's current value is 0. For dot in range, what is 0 plus 1? 0 plus 1 is 1. So how many times does this block of code currently execute? Once. So do this once. Stamp, meaning draw at the very beginning and move forward 50. And if we note, so that's going to be basically our gap. So move forward. I'm going to draw a little X to give to kind of just note where my turtle is currently, right? Because it's a bit hard for me to kind of just do that. Turtle is there. So we've done these lines. Then bob.right 90. Now, we always start facing this way. So turning right 90 degrees means now we are facing this way. Forward 50. We got to go forward 50. So we are now going from here, from this position, this X position. Whoops. We're going from here to being here. Let's go ahead and move this over here. So we're going from here to being over here. So now another right 90. So we were facing this way. Now we need to face this way. So because we started this way, we turned right. Now we turn right again. Now we tell Bob to move forward 50 times row plus 1 again. Well, what is row? Row is still 0. So that is 50 times 1. So he moves forward 50. So we move from here to here. Make sense? And then we turn right 180. So we're facing this way. We're turning right 180, which means we face the other way. So if we think about it for a second, right? We start this way, then we turn 90, 90, 180. Oh, that is 360 degrees. So when we're done with this loop, we are facing the same way we started. Make sense, everybody? Okay? And right now we are right here and we're facing this direction. Okay, row is now equal to 1. Don't let the fact that it's a nested loop scare you. Once you figure out like the first 2 or 3, you're going to get the pattern. These are all basically figuring out the pattern. Okay, and that first one's always whatever. It's the second or third one that the parent pattern starts to appear. Second one, the pattern starts to appear. The third one confirms it. So row is equal to 1. So now, for dot in range 1 plus 1. Math is easy there. That's 2. So we do this 2 times. Bob.stamp. So we stamp here. Move forward 50. Do it another time. Bob.stamp, move forward 50. Turn right 90 degrees. So now we're going to face this way. Move forward 50. We're over here now. Turn right another 50. So we did this, right 50, move forward down here. We're now facing this way. Move forward 50 times row plus 1. 1 plus 1 is 2, so move forward 100. Now that seems a bit tricky, but we moved forward 50 plus 50, right? So we moved forward 50 once, then we moved forward 50 again. So that was our 100. So moving back forward 100 in this direction just brings us back to the same X position we started at. And then turn 180 degrees so that we're facing the correct way. Now, row 2. I think most of us are seeing the pattern now, right? And if not, we're about to. So now row is equal to 2. 4 dot in range, row plus 1. 2 plus 1 is 3. So we do stamp, forward, stamp, forward, stamp, forward. We're over here now. Turn right, move down, turn right, move forward 50 times row plus 1. 50 times 2 plus 1, 50 times 3. 1, 2, 3. So we're here, turn 180, face this way. Can everybody now draw the rest without having to figure out what the pattern is, right? We've got 5 rows, so it's going to be 4, and then 5. So this is just simply a triangle made of dots, okay? Generally speaking, I have rubrics for these kind of problems where I'll say, oh, you forgot to do the top one, that's minus however many points. Oh, you only did 4, or you did 6, what we call an off by 1 error, okay? And that's only so many. So in case we don't finish this all today, by the way, I will continue it on Thursday, okay? So it's more important to me that we work practice on doing these things because it is taking us a fair bit longer than I wanted, or expected. But that's fine because I wanted to make sure that I get these matters sorted away with. Okay, so complete the function below so that the turtle passed as an argument draws a square. Each side should be side long. We've done this in class a number of times, right? Which is just simply saying 4, and in fact, I'll just type it over here, right? Okay, we need to just simply do boop, boop, boop. Okay, import turtle, and then draw square. I need to define it. Def draw square is equal to Bob. And then side length, what did I put there? Side. Okay. 4 in range 4, because it has 4 sides, we're going to do, Bob is going to do what? He's going to go forward. And then, however big that is. And then Bob dot turn, right 90. Right? Draw square. Okay, and that's all I'm expecting from you. To test it, which is part of the reason why we don't do this, part of the reason why we don't do this on computer is because on an exam you're going to be making errors that you're going to go back and feel compulsively like having to fix if you did it on a computer. And that's just not going to be viable at your experience level, being able to fix errors that quickly. Bob is equal to turtle dot turtle Bob 50. So I draw it. It's going to instantly disappear because of just the way my computer, because I'm using this instead. That will stop that from disappearing. Great. So now what I need to do is, I think this will probably end up being our last one for the day. Using the draw square function, write a turtle program to draw the shape below. You may create more functions if you wish. Oh my, give me a second. Okay, hey, let's calm down. All right. So what I was trying to do was zoom in here, because I want to point out this is 4 squares. The pictures I'm going to have you draw are much less complex. We're talking second best-selling video game of all time complex, which is what? Well, actually, it's third now, I think, because I think Grand Theft Auto took its money for second place. First, of course, is what? First best-selling video game of all time is? What? That's third. That's the one that's the complexity I'm looking for. But the first best-selling game of all time is also block-related. Not that not as much as you'd think. Minecraft. Minecraft is the best-selling video game of all time. Yes.
I was going to say Roblox.
Almost. I don't know. But as far as money, I think Pokemon's at the top in terms of franchising. That thing's a moneymaker. Okay. Anyway, so this looks complicated, but again, what we've got here is 4 squares. 1 square. 1 square. 2 square. 3 square. And 4 square. So the question is, how do we draw that? Well, the answer is, I just drew that, right? Think about that for a second. I drew this square, and then I went over here and drew another square. And then I went over here and drew another square. So, draw a square, then draw another square starting at then move to the center of my square. And actually that holds because where's the turtle ended up? In the center of the last square. So draw a square, move to the center. Does that make sense to everybody? Okay? So it's just 4 squares overlapping each other. So I'm not going to bother drawing a separate function for this. What I'm going to do is that it's a for loop. I want to do the same thing 4 times. 4 in range 4. Now, before I continue, I do want to mention the equivalent version of this question. We have 2 on the exam. They're not nearly as difficult. One is basically all the code is there except for the numbers in the forward and the angle. So basically, you're just filling in the numbers. So you've got most of the code except for the numbers filled in the arguments. Make sense? And you've got the picture that you're supposed to get from putting in appropriately. Then the other one is I give you like a almost completed. I give you like, here is pick A, and here's the code for that. Here's picture B, which is very similar to A, but it has something added to it. Please insert the code. Please insert your addition to the code to make sure we go from A to B. I I'm just trying to be as specific as possible, but basically it's another fill in the blank, right? And the fill in the blank says, this is what you currently have. Please fill in the blank so that we get B instead. So for most of these, you aren't working from scratch like you are doing over here. Make sense? That's why I say this is the harder version. For blank in range, 4. So the first thing I want to do is draw a square, which is very easy because I just wrote a function telling us how to do that. Bob. And then I guess I'll do, you know what? I don't know what you're going to do, what number you're going to do, so I'm just going to put it inside for how big it's going to be. And I'm going to call it 100, but that's fine. Draw a square with this side length. That's great. Now, once I've drawn it, 1, 2, 3, 4, I need to move right here. Okay? So how do I move right there? Well, I need to move this way, half the way across the square, and then I gotta move half the way down the square, right? That's easier than thinking, oh, I turn 45 degrees and then move half of the square root of 2 of, you know, or half of this, of whatever this is times the square root of 2. Because that's just, yeah, don't want, that's too much trig. Okay, none of that, please. So we're going to instead go dupe, Euclidean, or Manhattan distance. So Bob dot forward to move forward. Side divide by 2, half the way across the square. Then Bob dot right, 90 degrees to turn down. Bob dot forward to move down. Side divide by 2. And then let's make sure he's just and again, I like to make sure my guy faces the same way at the beginning. Left 90. He turned right 90. He undoes that turn to turn left 90. Make sense? So now, if I run this code, 1, 2, 3, 4, and I've almost got it. Whoops. Let me show you what the difference is. Turtle dot done. 1, 2, 3. So the only difference is, in my answer, is my answer has this, adds an additional line right there. Make sense? Now on an exam you wouldn't be, this is part also why I put this on the practice exam and why I say this is a tougher question. Okay? Because you wouldn't necessarily even remember that about that bit or think about that. It gets overridden on the other parts. They're just part of the squares. So how to fix this? Very simply, when we're moving to our next square, don't draw. Bob dot up to move the pen up. Bob dot down to move the pen down. Again, this is why this question is harder than I would say the other questions. Close that, run it again, and now we see he doesn't draw, and then we draw another square, and draw another square, and we draw another square, and we're good to go. Now, if you want to get more practice on this one, this is where the extra practice comes in, where it's the exact same question where I made it hard part 2. Notice it's 0 points because it's the extra hard one. Where we draw this, and again, it's 4 squares. 1, and then 2, and then 3. Let's see. 1, 2, and then 3. And then 4. So it's a question of how do you draw this one, you know? Because of course you've got to start from a corner to draw these. Okay? I say of course, but that isn't kind of natural. That's a deduction you have to make. So that one is definitely good for extra practice. Now, we have 2 minutes left. I'm not going to dismiss. When we get back, we're going to work on these problems. I'm going to double check to make sure that they have a corresponding part on the actual exam. This part is done earlier in the exam. So we'll go over those. And then we also have these page of additional questions, which are, I consider, more extra hard questions. Now this one over here, Project Euler Problem 1, you might be wondering what the hell is that? Project Euler is a website of practice mathematical problems. This is problem 1 on that website, and you solve it by coding. And then a lot of these are just, again, other kind of good coding practice problems that we can work on, okay? If you're able to do these problems over here and can then figure out how to do other variations of them, you're probably going to be in good shape, okay? So, and again, the other question, if I were to just study one, though, it would be this question and some variations of it, and then this question as well. Just, how would you draw things? Oh, sorry, getting the turtle to draw thing. Most of my exam is going to be most of the points for turtle stuff, though, is the here's something, please draw it variety. There's not a lot of code writing on the exam. That's mainly in the practice exam because that's harder. Okay. All right, take care. I'm going to upload this and also the other classes' practice videos.